All right, the last extension that we're going to do with this BCA tables are called limiting reactants. And in the last two sets of notes, we've been looking at the BCA table, and I've given you information for one of the reactants, and I've just said that the other one was excess. Well, now we're going to look at what happens when you get information for both reactants, and you have to decide which one is going to be used up completely and which one is left over for excess. But to start, I want to look at grilled cheese. All right, with grilled cheese, you need bread, and you need cheese, and you need butter, but butter's kind of like a catalyst, so we're just going to ignore it for right now. So you have 32 slices of bread, and you have 50 slices of cheese. And the recipe that I like to use for my grilled cheese is I like to use 2 pieces of bread, obviously because I want a whole sandwich, but 3 slices of cheese I find really gets that good gooey cheesy mess in the grilled cheese. So this is the recipe that we're going to use, and like I said, butter is kind of more like a way to cook it and not really a recipe, so we're going to ignore that for right now. So we're looking at bread and cheese. Then we're going to set. Okay, so let's treat this like it would be a stoichiometry problem because we're looking for that limiting reactant. So we're going to BCA that recipe, all right? First thing that we do is we write out our balanced equation, which I've done for you. So you have 2 pieces of bread, 3 pieces of cheese, makes this 1 grilled cheese sandwich. Then we need to fill in the befores. So from the last slide, we know that we have 32 slices of bread, and we have 50 slices of cheese, but sadly, we have 0 grilled cheese. All right, so then now we need to concentrate on the change. And this one is a little more difficult because do we use up all of the bread or do we use up all of the cheese? So you kind of have to do a little proportion to figure out which one you're going to use up. So let's start with the bread. Okay, and we have 32 slices of bread, and we're looking for X slices of cheese. This is equal to, in our reaction, our proportion is 2 pieces of bread to 3 pieces of cheese. If you do your cross multiplying, so this times this, and this times this, and then divide by 2 to get X by itself, it comes out to be 48 slices of cheese. If we go the other way and say cheese, we have 50 slices over X bread equals 3 slices of cheese for every 2 slices of bread, and we find that the cheese, or the bread in this case, would be 33.3 slices of bread. Well, that's a problem for us. So we have, if we use up all of our bread, we only need to use 48 slices of cheese. We have 50 slices of cheese, so this one works. If we used all 50 slices of cheese, we would need 33.3 slices of bread. But we don't have 33 slices of bread, so we can't use up all of our cheese. So we're going to put these into our BCA table. So we are going to use all of our bread. So we're going to subtract out 32 slices of our bread, and then we're going to subtract out 48 slices of cheese, because if we use all 38 slices of bread, our proportion tells us that we're going to use 48 slices of cheese. Now, if we make 32 slices of bread, and that's a 2-to-1 ratio to grilled cheese, we would need half of that 32 in making the sandwich. So 32 slices of bread, half of that would give us 16 sandwiches, which sounds like a pretty yummy meal to me. Okay, so we need to figure out the after. Obviously, we are using all of our slices of bread, so that means we would have 0 slices of bread left. But really, if you make your grilled cheese, do we really need any bread left? I don't think so. Now with the cheese, we had 50, we used 48, so we're left with 2 slices of cheese. And I have a puppy who loves cheese, so I'm happy with that, because I'll just give those slices to her. Now with our grilled cheese, we started out with 0, but we made 16, so we're left with 16 slices, or 16 grilled cheese sandwiches. So in looking at all of this, we have come up with 2 slices of cheese are left over if we use up all of the bread. This means that our limiting, what stopped the reaction from continuing on, was the bread. This one was limiting. We used it all. We don't have any more left, so that one limited the number of grilled cheese sandwiches. Really, we could have gone and made 2/3 of a sandwich if we used these last 2 slices of cheese, but that just wasn't available for us because we ran out of bread. All right, so let's look at this in terms of chemistry instead of food. So the limiting reactant, this is the one that gets used up. Okay, this one determines how much product we have made, how quickly it's going to go through. So the one that gets completely used up is called our limiting one. They limit the reaction. Our excess reactant, which that's a term we've used before, is the one that's left over. There's excess, there's extra. And usually we label that as, get it, XS, yay. Okay, but this one is the one that is left over. We have some of these pieces left. Let's look at a real example. So we're going to look at hydrogen and oxygen, and if you burn hydrogen in the presence of oxygen, you get to make water. So I've put our balanced equation up here for us, and we need to fill in our befores. So we have 4 moles of hydrogen gas, so we're just going to put a 4 in here, and we have the same amount, 4 moles of oxygen gas, and they are going to make water, but we haven't mixed them yet, so we have 0 moles for our water. Now, we need to decide how much of these we are going to use. So to do the change column, or the change row, we need to say, are we going to use up all 4 of our hydrogen or all 4 of our oxygen? And that's where we do the proportions again. So we have 4 moles, it's not a very good color, 4 moles of H2 over X moles of O2 equal the same as 2 moles of H2 and 1 mole of O2. And I get these proportions from here and here. If I cross multiply these, I end up with X equaling 2 moles of O2. Well, I think we can stop right there because we have 4 moles of oxygen, but if I use up all of my hydrogen, I only need 2 moles of oxygen. So we could stop. But I'm going to continue on, and so what happens if we use all of our oxygen? So if I use 4 moles of O2, and I'm looking for how many moles of H2 I need, I would have 1 mole of O2 over 2 moles of H2, and that would give me X equaling 8 moles. Well, I don't have 8 moles. I have 4 moles. So I can't use up all of my oxygen because I don't have enough hydrogen left. So we're going to fill this in our BCA table. We're going to use up all 4 of our moles of H2, and we only need to use 2 moles of our O2, and we are going to make 4 moles of water, because for every mole, or when we use 2 moles of hydrogen, we make 2 moles of water. So this is what our change looks like. Now to figure out how much we have left and how much we've made. So with the H2, we started out with 4, we used 4, so we have 0 left. For the water, we started out with 4, we used 2, so we're left with 2 moles. For the water, we started out with 0, made 4, so we're left with 4. Okay, so to answer our question, we were looking at if we use 4 moles of hydrogen gas and 4 moles of oxygen gas and we made water, what is going to be our limiting? Well, we had 2 moles of O2 left, so that means O2 is the excess and H2 is our limiting. It stopped the reaction. We weren't able to continue to make more moles of water because we ran out of H2.